This conference will now be recorded.
All right, let's let me find my presenting button. Okay, move things around just a second. All right, can everyone see my desktop?
Yes.
Yes.
Okay, good.
Yes.
All right, so good morning, everyone. Thank you for the opportunity to present. Happy New Year. Before the New Year, I think if you remember, I did a pretty brief introduction on matchmaking between use cases and the die-to-die interfaces. If you remember my presentation on December the 3rd, if I'm not mistaken. So today is a follow-up presentation. Let me move my cursor. And the topic of today's presentation is testing heterogeneous integration and supply chain implications. These two topics are not closely correlated, but thanks to Bobby, I am able to assemble them together as a series of my presentation. Okay, now I can move. That's the cover page, today's topic. Outline of today's talk, I'm going to cover concept of heterogeneous integration, architecting, testing, and reworking heterogeneous integration. And lastly, I will bring up a RACI matrix to explore the responsibility, accountability, consultation, and inform structure that we can potentially use for structuring supply chain management for heterogeneous integration. So why heterogeneous integration? We have seen this slide or different formats of it many times. Mainly, we want flexibility, lower cost, lower waste, higher yield, and shorter time to market. Those are the key reasons why we want to pursue a true heterogeneous integration for our industry. When it comes to business models, it's kind of interesting where to look at where we are as of today. If we look to the left side of this slide, in the monolithic SoC days, we are kind of building a switch army knife where we want our device, semiconductor device, to do a lot of different things at the same time. Now we are kind of in the middle of this graph where we resemble a Lego type of a business model where everything is patented, tightly controlled by a handful of elite semiconductor players in our industry. It's a club of limited players who have money or deep pockets, if you will. Not everyone else can play simply because of the affordability, relative affordability of this game. So for people who can play, they can patent, standardize, and collaborate on well-defined customer interfaces between different Lego blocks. This is pretty much where we are as of today. We're in the middle of the Lego business model for heterogeneous integration. Where we are going to pursue or where we are going to is the IKEA business model, in my humble opinion, where off-the-shelf chiplets will be freely distributed and marketed across the whole industry, where pretty much ideally everyone can play, everyone can afford playing this game of heterogeneous integration. This is pretty much the holy grail, but the eventual, the ultimate goal that we're shooting at. So in this transition of business models from Swiss Army knife through Lego all the way to IKEA, obviously, as the audience can appreciate, there will be a number of major changes in terms of priorities. Transistor scaling, namely Moore's law, will pretty much give priorities to die-to-die interconnects, advanced interfaces between chiplets. The importance or significance of SoC development will pretty much also give priority to package / device co-design, co-development efforts. And testing of heterogeneous integration will also, the importance of testing will also become pronounced as we move along with the heterogeneous integration business model development. So when it comes to architecting heterogeneous integration, I use this slide often to explain to my clients or my colleagues the change in roles specifically for OSAT people. So if you look at the top, traditionally when it comes to advanced packaging, we just, as OSAT player, we just dice up the chips, IC dies, and then do all kinds of mechanical / electrical assembly work in order to ship the final package products to our customers. We're kind of like our role is more like a builder. So we have all kinds of materials, building materials like bricks, like what have you, and then we design to print. We don't really think like an architect. We think like a builder. Our customers are the architect. They tell us what they like their houses to look like, and we just build to their blueprints. In comparison, when we move on to heterogeneous integration, the OSAT people will need to think more like an architect instead of just a builder, where we need to have say or more impact in the overall architecting effort or endeavor for building a house, so to speak. So that's a role change for OSAT industry. We have seen this slide before the new year. I don't plan to dwell on this further. We talk about different applications of heterogeneous integration, ranging from server HPC all the way to networking to AI accelerometers. So different applications have different packaging / design implications. So when it comes to architecting heterogeneous integration, we need to be fully aware of these differences in applications and requirements. So we also seen this slide before the new year. We talk about different die-to-die interfaces for different use cases or different applications. I took the liberty to highlight some die-to-die interface standards suitable for certain use cases in practice. So we went through this slide before the new year. So if you have any questions regarding this exercise, feel free to contact me offline. Today, I'm not going to spend too much time repeating what I presented before the new year. From an architect perspective, as an architect of heterogeneous integration, we need to ask us a series of questions before we finalize our designs or specifications. These questions include, but not limited to, how to build necessary redundancy into die-to-die interface for testing or reworking. So as an architect, we not only need to worry about die-to-die interfaces and signal integrity, we also need to worry about testing and reworking in a production environment for heterogeneous integration. Can we really rework a chiplet? Can we switch on or off a certain chiplet for rework? Is it possible to rework microbumps? Is it even possible to rework direct hybrid bonded interconnects? When we rework a chiplet, do we need to redo static timing analysis or RLC extractions for timing purposes? Do we need to redo our PDN power distribution network analysis for the whole system if we elect to rework just one piece of chiplet? Is it worth it? So those are the questions we need to maybe not necessarily answer upfront, but at least take into consideration when we design the heterogeneous system as the architect. So when it comes to testing,
Michael, this is DJ. I have a quick question on the previous slide. So there are you list so many different die-to-die interfaces which industry is looking at. Do you think OSAT players have any role to play to actually find convergence within industry to make sure that there are not too many approaches for die-to-die interfaces, but a few, and that way it makes industry move in direction in a faster manner than to fragment the industry with many different types of interfaces, and then it becomes difficult for folks to figure out what is the best approach for the solution. So do you have any thoughts on how industry can converge on few solutions, ideas, or are we in the early stages where we should let proliferation of different interfaces? Any thoughts on that part?
Absolutely. I think, thanks for the question. That's a great question. I think we are in the middle of making a critical decision. I think we are already past the time stamp where we allow for a variety of different standards to flow around, so to speak. If you listen to my talk before the new year, in my call to action slide, I actually strongly recommend the industry, the whole community, to come up with some kind of convergence, so to speak, so that we can downsize our overall scope when it comes to defining and proposing die-to-die interfaces. There, if my count is correct, there are over 18 different die-to-die interface, different versions, different editions from different variety of standard bodies floating around, if you will, that pertain to heterogeneous integration die-to-die interfaces. That is, as the main purpose of my talk before the new year, I want to make some connection between these die-to-die interface standards and real life or real world use cases or applications, specifically concerning finished goods, finished packaged products that we are going to eventually use, we eventually ship for heterogeneous integration. So I just want to raise the question before the new year. so that the community can go back and think about this. You know, I don't have all the answers. Obviously, I'm not, entitled to or authorized to make selections which standards to use eventually. But at least I want the community to take into consideration we are already past this timestamp where we need more die-to-die interface standards. We already have more than enough. And in my personal opinion, I think we have a lot of duplicates already, meaning maybe 2 or 3 different standards will have essentially pretty much the same or comparable performance matrix. They just have different names or different terms.
If I may add just a little bit, folks, if you don't mind, because I tried with Bobby and a few folks actually, for example, to compare, quote unquote, OpenHBI versus Bo, because they looked like they had very, very similar capabilities. And we put in the 2 teams together. I know Bobby tried to do that. And to be very honest with you, to be very frank with you, some part of it becomes more of a, like they're fighting each other, who can do
competition.
Competition, exactly. And it became very, very, very difficult. And I think the conclusion was, hey, Bobby can jump in and rather than try to do this because it's not going to work, nobody's going to say, yeah, this interface is inclusive, so let me drop this one or drop that one. At least for this community, to go and be very, very, very clear and put in a very, very simple way the particular unique, things about each interface. For example, one maybe require, silicon interposer, big features that is a customer looking at area, cost, performance, that kind of thing, and where it's very clear there's a superiority in one, vector versus the other. Just we as a community do that summary and make it very, very easy, at least, for anybody to figure out which standard they're going to choose, rather than actually try to reduce them, because I don't know, it turned out to be extremely difficult. I don't know, Bobby, if you want to comment, but at least that's my experience from, my conclusion from the experience we had on this D2D interface.
This is Alan. I'd say here, great discussion, guys. Exactly what my points have been. So the only thing that I would say is, Michael, I like the Swiss Army knife, the Lego, and the IKEA diagram as well. And obviously everything in the challenges there. I've been at the enablement of the community, right? You've got the geniuses that have got all the money, but if we're making an industry standard, it needs to be for the wider industry, the tier 2s and tier 3s, to be able to participate. So when you go to XSR, like you've got in the organic one there, even at 112 gig, it is possible to make it pluggable. And then you've got, if you've got a faulty die, it's much easier to change it. And so that's the simplest and the most adoptable end of the scale, where you've got these dies, they're close enough together, but there's a socket between them of some sorts. And so therefore they're much more serviceable. And I'm an architect, I'm a systems architect. I only have the ability to buy components and plug them together. I don't have millions of dollars to actually even put an organic substrate together with all these die on it, because they're still, so we need to enable the systems side as well, guys. And that's going to get you the broadest community. We need to think back to the 1980s when we had little chips that we all, we wire wrapped together on a board. We're really reinventing TTL here. And we do need the one standard, as Michael was saying, really. And by the way, I do get it. The chap that was just last speaking. Yeah, if you do have the money for a silicon interposer, there's a standard for that. If you're happy to put your organic and you want the sub half a picojoule per bit, yeah, you can go on an organic substrate and maybe do that. But having the pluggable one is what nobody is thinking of in this, and on the business side. And that's what's frustrating me about this group is I get crickets. Everyone likes what I present, but nobody is thinking about it from the tier 2, tier 3 players. To be fair, I mean, you're all thinking about it because you're all Facebook or Microsoft, or you're huge companies yourselves. And I'm trying to represent the community you're trying to get out to. And I think Michael's doing a great job in this presentation of saying there's a wider community out there, guys. If you want this adopted as a open standard, then you got to let everybody play in this field, and then you'll be successful. At the moment, it's the billionaires club going to the hundreds of millionaires club is what you guys are talking about, which is fine. I mean, if that's it, maybe that's what you want to define. But I'm saying, hey guys, let's think about the tier 2s and 3s, or the tier 3s out there. Anyway, sorry for the rant.
Thank you. Bobby, do I have 10 minutes more to my budget?
You can take all the time you want, Michael. This
Okay.
is you're obviously provoking a discussion. Keep going.
Okay, thank you. Thank you, everyone. So I agree with everything the audience just mentioned. So I think
And
that the customers...
So just to close on to respond to Taufik directly, I think our group's stand has been to create objective metrics that users can look at and draw their own judgments rather than trying to sort of impose our opinion on the data.
Exactly.
So that's roughly where we're at. Even if there is a hint that there's a proliferation of standards, the general consensus has been eventually the market will decide one way or the other.
Yeah, I think one of the concerns is also when the open source community has two standards, right? Like the Open HPI and the BOW, and there's no real recommendation one way or the other, and it's hey, you guys go figure it out and decide.
Well,
for smaller players, it is non-trivial to figure out what the right way to go is.
Well,
So,
Yeah,
to be fair, there are multiple open standards, right? Not open source, excuse me. It's just that where ODSA has two, but in reality, the world offers you there's
right, no, like AIB is open source. I mean, in theory, right?
XSR is open. I mean, they're all open standards. You may not get open designs, but they're all open standards reasonably.
Yeah, but Bobby, like you said, if you manage to find a way to publish a comparison that is objective, purely objective, not necessarily, what is driven by the folks developing that standard, I think that goes a long way in helping, like Anu was saying, maybe smaller companies or other folks to go and make. And I think that comparison, if you manage to do it objectively and on the big stuff, okay, I don't need to compare if this is 1.5 joule femtojoule per bit or 1.45, but on the big stuff like this will require organic versus this required. I think it goes a long way in helping out people versus just reading spec and trying to go figure out what to believe in it and how they can. I don't know.
So yes, so to Anu's point, yeah, you're still on. To Anu, look, I think what we can do, which we tried to do 2 years ago or 3 years ago in the paper with Greg Taylor, there's a second leg to it, which is given a use case, what matters to you? What are the attributes for that use case that matter to you? And then how do you map the objective metrics by which you're comparing die-to-die standards to that use case? And I'm hoping, I think some of the spreadsheet can filter down in that direction. And then Anu, if you combine the spreadsheet and the objective metrics, I think an answer will pop out. So if a company knows what it's building products for, the use case should guide you, should tell you which metrics are more important through the spreadsheet. And then the objective comparison spreadsheet should tell you which interface best meets your needs.
Yeah, I agree. The spreadsheet actually is extremely useful. So I greatly appreciate, and Shahab actually forwarded me his latest update, and I think it's extremely useful. It's relatively non-trivial, Bapi, and the net results, I don't want to get the wrong answer because it affects probably a series of products in a fairly harsh way if we got something wrong there. So.
Right. So what I'm hoping is the spreadsheet you guys are building, you, Mudassar, and Javi, sort of takes a product's requirements and maps them out into attributes that you care about. And that's the second half of the puzzle, so to speak. But anyway,
I agree. And to that effect, I am still interested, and as I indicated in the survey you ran, on trying to work with the OSATs and foundries to say which I can scale up or down. Otherwise, my
survey, everyone, it's in your chat window.
There you go. Anything for you, Bapi.
Michael, coming back to DJ's original question, do you think OSATs can drive convergence, or they're going to be they're sort of going to let the customers drive the convergence?
Well, OSA, I don't think OSA can drive the conversion because we are not the. Let's face it, we are not the driver of this community. We are more like a participant of the community. But I think OSA does have a say in terms of the finished good, final assembly, and also the testing aspect, which I'm going to touch upon later on in my presentation. Because when we think like architect, we also need to take into consideration what happened after we design the interfaces or the whole assembly. We need to test it. You know, we need to test it before we can ship it. So that actually is a non-trivial at all if we think about it, which I'm going to briefly introduce to the audience today.
All right, thank you.
I think the customers also need to step up and play a more pronounced role in this whole, matchmaking process, so to speak. The end customers like Meta, like Microsoft. I'm not saying they haven't done enough. They have done a lot of work so far, and I highly appreciate their inputs. Sometimes they talk directly to our, to OSEC people like us about, heterogeneous integration. How much time and resource can I actually get? Can I actually save by going into heterogeneous integration? What does this really buy me? As OSA, we cannot, at this moment, we cannot answer those questions. So that's why we need this community's help to figure out. One of the pending question is, like I mentioned before the new year, which standard or standards should we go after? Because as OSA, we have limited resources and budget. We cannot just go after everything along with our customers, although our customers ask us to do so. But at the end of the day, we have to be very selective when it comes to standards and interfaces. All right, so without further ado, let me shift gear to testing.
Sorry, I had a question on the previous slide. Sorry, I'm sorry. If you go back, just in the middle column, this integrated fan out. So there are two things here. It's saying data rate of 56 gigabit per second. So this is, USR falls in that category, but parallel interfaces don't go that high, right? And also that's one question. Second is that for, at least we have been looking at for OpenHBI, is still fine pitch, but info as an option also, right? As a technology for interconnect. And 2-layer info versus 4-layer info, all of that, those are options. But info, I thought, it still fell in the category of a fine pitch interconnect.
Yeah, I think we can, if I may, I would like to, dive into the details offline. I do have a spreadsheet of of these standards and the potential figure of merits parameters for, you know, air. In my presentation before the new year, I cited this study done by IR Labs. I encourage the team to go back to what they have done. I'm sure there's a update to their spreadsheet, and then we can you know, look at those spreadsheets together offline so that we can figure out what's the best figure of merits for different package types, different applications.
Okay, sounds good. Yeah, we should do that. I think it's just second middle category. Some data seems inconsistent there, but we can even.
Hey, Buffy. Buffy, if
Yeah, I'm here. Go ahead, Swami. Wait. Can anybody else hear me?
Yeah, we can.
I can hear you, Bobby.
Okay. Then it's just Swami. All right.
Swami, are you on mute?
If I may, to Anu's point, yeah, we believe the uh, semi-company you know based on number of access on with
it's Swami.